Hello, beautiful people. Today we're going to be talking about 9.8. Our SWABAT is to factor polynomials completely. Factor polynomials completely. So we're going to start with this first slide. So number 1 and 2, they're going to help build us up to what's coming up ahead. So for number 1, we have 3x times x plus 5 minus 7 times x plus 5. If you look at these two terms, they both have something in common. What might they have in common? Well, your first one has x plus 5, and so does your second one. So in common, they both have x plus 5, so I'm going to factor that out from both terms. And just as you've done before, I'm going to put the leftovers in parentheses. So if this x plus 5 is gone, what's left is 3x. And then from this one, the x plus 5 is gone. So what's left? Minus 7. Once we took both of those out. That's it. These both were in common, so we factored it out. We only write it one time once we factor it out. It's just like if you had xy plus zy. Well, they both have a y in common, but left over, once this y is taken out, just an x. Once this y is taken out, just a z is left. That's what we've just done. Let's try it for number 2. I'm looking at this, and right off the bat, it doesn't really look like they have anything in common. However, it's close. This is y minus 9, and this is 9 minus y. Let's look at this 9 minus y for a moment. First thing I want to do is write it in standard form, which is negative y plus 9. I'm getting closer because I have y minus 9 and I have negative y plus 9. The only difference between this and this is the signs. So I'm looking at this, and my leading coefficient is negative. It's like having a negative 1 in front of there. So I'm going to factor out a negative 1 from both of these two. And when I do, I have y left over because this negative 1 is now out. And then what times negative 1 will give me a positive 9? Negative 9. Now I'm looking at the same thing here. So here's what I didn't do. I didn't do anything with this. But here, plus 3 times, I'm going to rewrite this now as negative 1 times y minus 9. Looks like a mess. I don't like it. So, again, I'm not going to do anything with that, but, well, actually, it's not going to be plus. So, I can multiply these two. So, what's positive 3 times negative 1? Negative 3. And then y minus 9 is still there. Now this looks a little bit more user-friendly to me because I have 2m squared times y minus 9 minus 3 times y minus 9. So what do they both have in common now? Y minus 9 is my common factor, excuse me. Left over, this is now gone. So I have 2m squared. This is now gone because we factored it out, minus 3. And that is that. The next one, factor the polynomial. So we have 4 terms here, which is kind of different from what we've done before when we did our factor boxes. So it's also known as factoring by grouping. So I'm going to group these two together and these two together. Factor by grouping. I would write this here. Factor by grouping. So I've grouped the first two and the second two, and it's always going to be that way. When you have 4 terms, group the first 2 together and the last 2 together. So now that I've grouped, let's factor. What do 2d cubed and negative 10d squared have in common? Where I look at 2 and the negative 10, and they both have a 2 in common. D cubed and d squared. How many d's can I take out of both of them? Go with your lowest exponent, so squared. Left over for this term is going to be d. Because the 2 is gone. I had 3 d's, I took off 2, I just have 1 left over, minus, except we know we don't really write that 1 because it's kind of not a good look. 10 divided by 2, that's the bell, kind of irritating, is 5. And then I took all the d squareds out, so that's nothing left is there. Now for these two, 3d and negative 15, they both have a 3, a positive 3 in common. Left over, if I took out the 3, I still have a d there, minus 15 divided by 3 is 5. Almost done. Now we're going to do what we did before, and I'm going to tell you. If when you factor by grouping, you don't see that they have something in common, for us and for where we're at, that means we did something wrong, because they will always have something in common. So I'm looking at these, and they both have d minus 5. So I'm going to factor out d minus 5. And then left over, this is gone, so I have 2d squared. This is gone, plus 3. And there you go. Okay, same thing for this one. It looks like they're already similar though. So I'm going to factor by grouping. First thing we do is group them. And then I'm looking at 2x cubed plus 3x squared. There's not a number aside from 1 that goes into 2 and 3. So then I'm looking at x cubed and x squared. And I can take x squared out of both of them because I'm just looking at the lowest exponent. And then what's left over for this one, the 2 is still there because I didn't take out a number. And then I still have an x because I had 3 and I took off 2. So I still have just an x to the first power here. Plus, I didn't take out a number, so that I still have the 3. And all my x squareds are gone, so I'm going to close that parentheses. Now, I stopped looking at this altogether. If you wanted to, you can put your fingers over it and then just look at negative 2x minus 3. What do they both have in common? Well, there's not a number other than 1, but because my leading coefficient is negative, I'm going to factor out a negative 1. Because this doesn't have an x with it, no x's can come out. So it's just a negative 1. So negative 1 times what gives me negative 2x? Just 2x. Negative times positive 3 gives me negative 3. Basically, whenever you factor out a negative sign, you just change all these signs here. Now I'm looking at it, and it looks like I did it correctly because I have the same thing here and here. So I'm going to factor that out. 2x plus 3. Left over is x squared minus 1. Now, this is where all the magic happens. It's good stuff. We can do a little bit more. So if you remember the special products, we're going to use one here. The special product that I'm going to use is a squared minus b squared. And that's equal to a plus b times a minus b. So for me, this is 2x plus 3 is equal to, I have 2 sets of parentheses. So just the same way I had to break down this a squared as a and a, this x squared will be x and x. This b squared, well, what squared gives me 1? 1. 1 is plus and 1 is minus. Sometimes I like to throw in the 1 in there because people seem to think that it doesn't really exist. It doesn't really count, but it does. Okay, number 5. I'm going to factor by grouping, so go ahead and group and group. And if you're feeling good about this, go ahead and press pause and then fast forward through my explanation if you'd like to. And then check to make sure you get the right answer though. So x cubed and x squared both have an x squared in common. Left over, if I took off 2 from 3, I have an x plus, well, what times x squared gives me x squared? Not 0, 1. Plus, what goes into 4x and 4? 4. And then what's left over here? If I took off the 4, I have an x. Plus, if I took off the 4, I have a 1 as a placeholder. Now these both have an x plus 1 in common. And so left over, I have, I'm sorry, yeah. From this one, this is gone, so I have x squared plus 4. And this will be my final answer. The reason why we can't do anything more is because for the special product to work, it has to be a squared minus b squared. It has to be a subtraction sign there, and I don't have one. So because this is plus, I'm done for that one. Okay, next thing. Factor the polynomial completely. Slightly different, but not so bad. So I'm looking at 7x cubed minus 63x. What do they both have in common? 7. That's for sure, because 7 goes into 7 and 63. And this has x cubed and this has x, so I'm going to take out an x. Left over is x squared for this one, because the 7 is gone. I had 3, I took off 1. So I have x squared minus 7 times what gives me 63? 9. There's no more x's because I factored that out. Now this is again that special product, a squared minus b squared, and that equals a plus b times a minus b. So this is going to be 7x times, what squared gives you x squared? X and x. What squared gives you 9? 3 and 3. Give one a plus sign and one a minus sign, and you have now factored the difference of two squares, excuse me. Okay, let's try another one. We have 3x4. So here's another hint. When it says factor completely, before you go to a box, you want to check to see if there's anything that you can take out of all of your terms. So I'm looking at 3, 30, and 27, and I see that 3 goes into all of those. And I have x to the fourth, x cubed, and x squared. So I'm going to take out an x squared from all of those. Leftovers will go into parentheses. So for this first term, the 3 is gone. I had 4 and I took off 2, so I have x squared left. Plus 3 goes into 30, 10, with 1 x left over, because I had 3 and I took off 2. Plus 3 goes into 27, 9 times. Looks like a perfect square. It's not, though. Because in my mind, if you're thinking about your perfect ones, it would be x plus 3 squared. But when you check it with the 2ab, it doesn't work. So I'm going to have you trust me here and know that you have to do a box. First term, first box. Last term, last box. And I need two numbers that will multiply to give me 9x squared, and that will add to give me 10x. 3 and 3 don't work. That's why this didn't work out for me. But 9x and 1x do work. So factoring, these both have an x, these both have a 9, these have an x, and these two only have a 1. So this 3x squared, I'm going to rewrite it because it's a factor. 3x squared times x plus 9 times x plus 1. And that's it. Okay. One more. Let's look at negative 4s cubed t cubed, 24s squared t squared, minus 36st. So looking at the numbers first, negative 4, 24, and negative 36. They all have a negative 4 in common. Now for the s's, I have 3, 2, and just 1, so I'm going to take out an s. T cubed, t squared, and t, and a t. Basically the smallest one I'm going to take out, so st. Left over, well there's not a 4 anymore, so that's gone. If I had 3 s's and I took off 1, I still have s squared. And I had 3 t's and I took off 1, so I have t squared. Not plus, just kidding. Minus, because 24 divided by negative 4 is negative 6. I had 2 and 2, so this is just going to be st. Plus, because negative 36 divided by negative 4 is a positive 9, and my st's are gone. So for this one is a perfect square trinomial. So it's negative 4 st times st minus 3 squared. And I'll show you I'm using this rule. What squared gives me s squared t squared? St. What squared gives me 9? 3. And then I can check it by just doing negative 2 times a, which is st, times 3, which is negative 6 st, which was my middle term there. That is factored completely. Okay, so for the rest of this time that you have, please start your homework, which is for 9.8, and I will see you next time. Thanks. Bye-bye.